Hello everyone and welcome back. In our last lecture, we explored the fundamental data structure in JavaScript, array and string. We learned how they organize data and crucially the time complexity of common operation, helping us write more performant code. Today we are diving into three more powerful and flexible data structure, object, map and set. While array are great for ordered list and string for sequence of characters, object, map and set provide unique way to store and retrieve data, particularly when you need to associate value with unique key or ensure uniqueness within a collection. Understanding these will significantly expand your toolkit for organizing data efficiently in your JavaScript application. An object is perhaps the most fundamental data structure in JavaScript outside of primitive type. At its core, an object is an unordered collection of key value pair. Each key is a string or a symbol, which we won't cover today, and it maps to a value, which can be any JavaScript data type, like another object, an array, a string, a number, a boolean, or even a function. Think of an object like a dictionary or a physical address book. You look up information as value using a specific word or name as key. For example, we declare a variable user and assign it an object later. Inside the curly braces, we define three key value pair, name with the value Alice, age with 30, and is active with 2. To access a value, you use either dot notation or bracket notation with the key. Both are typically very fast, averaging below 1 or constant time. Because JavaScript engines are optimized to quickly find value based on their key using hashing internally. So, question is, what is hashing? Imagine you have a library and you want to find a book quickly. Instead of searching every cell, you use a system. You take a book title as a key, run it through a special hashing function which generates a unique code that has value. And this code tells you the exact shelf number where the book is located. That's essentially how the hashing works for object. The key is passed through a hash function which computes an address in memory where the value is stored. This direct lookup makes operation fast on average. Since objects are mutable, you can easily add new properties or modify existing one. These operations also average of below 1 operation. You can also delete properties using the delete operator, which is also an average below 1 operation. It's important to remember that while object provides fast average access, insertion and deletion, they do not maintain insertion order of key in the older JavaScript environments. Though modern JavaScript engine generally preserve insertion order for non-integer key. However, for guaranteed order, maps are often preferred. Just like array, you will often need to iterate over the content of an object. JavaScript provides several methods for this, all of which generally involve a linear type, big O n, complexity, where n is the number of properties in the object because they must visit each property. The object key method returns an array of an object on property value. Here object.key car takes the car object and returns an array containing only its key, make, model and year. Object.value returns an array of an object's own values. Here object.values car returns an array containing only the values from the car object, Toyota, Camry and 2020. And object.entry method returns an array of an object's own string key property, key comma value pairs. This is often very useful for destructuring in loop. Here, dot entry object.entry car returns an array where each element is itself an array containing a key value pair from the car object, like me, Toyota. Here you can then iterate over this array using method like for each or for in loops, each taking big O n time for the iteration itself. Here we first get all keys using object.keysCar. Then we use the for each array method to loop through each key. Inside the loop, we use a template to print the key and its corresponding value from the car object. Finally, the for in loop iterates over enumerate properties of an object, including inherited ones. This is also an big O n operation. Here, the for in loop iterates over all enumerable properties of car. The if car.has own property key check is crucial. It ensures that we only process property directly owned by the car object, preventing us from iterating over inherited properties, which can lead to unexpected behavior. While these iteration methods are big O n, they are perfectly suitable for most applications. However, when dealing with very large objects or needing guaranteed order, maps often become a better choice. Next is map object. Map object offers a significant improvement over plain JavaScript object for certain use cases. Like object, map stores key value pairs but with some crucial distinctions. The most significant difference is that map maintain the insertion order of their elements. When you iterate over a map, you are guaranteed to get the elements back in the order they were added. Another key difference is that map key can be of any data type, including object, functions, or any primitive value. In regular object, key are implicitly converted to string or symbol. Similar to object, maps also use a hashing mechanism internally to achieve their average big O1 performance for lookup, insertion, and deletion. The difference is that the hashing algorithm for map is designed to work efficiently with various data types as key, whereas for plain object, key are stringified for hashing. For example, here we create an empty map object by using the new map constructor. To add value, use the .set method. Setting a value is an average big O1 operation here. Here, user roles .set admin, John Doe adds a key value pair where the key is the string admin. Next, user roles.set 123, Jane Smith adds a key value pair where the key is the number. This would be stringified to 1 to 3 in the plain object, but in a map, 1 to 3 is retained as the number. And in next, user roles.set user object, Peter Jones adds a key value pair where the key is an actual JavaScript object, user object. This is a powerful feature of maps, as object cannot be direct key in plain JavaScript object. To get a value, use the .get method. This is also an average big O1 operation. Here we retrieve value by passing the exact key that was used during insertion to the get method. To check if a key exists, use .has method, which is big O1 operation. To remove a key value pair, use .delete method, that is also big O1 operation. Here user roles.has admin checks if the key admin exists in the map. User roles.delete 1 to 3 removes the key value pair associated with the key 1 to 3. And user roles.size returns the number of key value pair currently in the map. Maps are ideal for when you need to store key value pairs where key can be a complex data types or when the order of insertion is important. Next is set. Set provides a collection of unique values. Think of a set as a list where every item can only appear once. If you try to add a value that already exists in the set, it simply won't add it again. Sets are incredibly useful for the task like removing duplicates item from an array, keeping track of unique IDs, checking the presence of an item very quickly. Similar to map, set also leverages hashing internally to efficiently store and look up values. When you add a value to a set, it hash is computed, and this value is used to determine if the value already exists or where to store it. This is what allows for the fast average before one operation. For example, here we create an empty set object using the new set constructor. To add value, use the .add method. This is an average before one operation. If the value already exists, nothing happens. Here you can see we add 10, 20 and 30 to the set first. When we try to add 20 again, the set checks if 20 already exists or not. Since it exists, the operation does nothing, maintaining the uniqueness. To check if a value exists in the set, use the .hash method. This is an average before one operation, making set excellent for quick lookups. Here the .hash method efficiently checks for the presence of a value within the set. To remove a value, use the .delete method, which is also an average before one operation. Here, unique numbers.delete 20 remove the value 20 from the set. Unique number.size return the number of unique value in the set. Here, set like maps also maintain insertion order when iterated over. You can easily convert an array to a set to get unique values and then back to an array. Here, new set number with duplicate create a set from the array, automatically removing duplicates. Then take all the unique elements from the set and spread them into a new array, creating unique array. Sets are powerful tool for managing collection where uniqueness is a primary concern. Let's see where these data structures shine in real web development scenario. Object like user profile or entities. When you fetch user data from a backend, it often comes as an object like ID 123, name John Lowe, email john@example.com. Similarly, we use configuration setting like we storing application setting like API keys or theme preference. API response most time JSON data received from APIs is passed into JavaScript object. Event data when an event occurs like a click or key press, the event object contains properties about the event. Maps we use for like caching. You can use a map to store previously computed result using the input as a key and the result as a value for faster retrieval. For example, caching data fetched from an API. Similarly, storing DOM element reference if you need a quickly access specific HTML element by a unique ID or custom attribute. A map can store reference to these elements. Keeping track of connected users in a real-time application, you might use a map where the key is a user ID and the value is the connection object. This allows for quick lookup and deletions. And for set, we can use it like tracking unique visitors on a website. You could use a set to store the IP address of visitor to count unique visits. Or managing tags or categories. If an item can have multiple tags, a set can ensure each tag is only listed once. Debouncing event listener. In advanced scenario, you might use a set to keep track of element that have already triggered a certain event to prevent multiple firings. Alright, let's quickly recap what we have covered today. Objects are your go-to for flexible, unordered collection of key value pair where key are string or symbol. They offer excellent average big O performance for adding, accessing, and deleting properties, primarily due to their hashing mechanism. They are ideal for representing structured data like user profile or API responses. Map build upon the key value concept, but usually they guarantee insertion order and allow any data type to be used as a key. This makes them superior for scenarios like caching, maintaining order, or associating data with complex objects. Like objects, their core operations are average big O, also powered by hashing, but with more flexible key handling. Finally, set provide a powerful way to manage collections of unique value. They ensure no duplicate exists and also maintain insertion order. Their average big O performance for adding, checking for existence, and deleting is also attributed to their hashing implementation, making them perfect for tasks like filtering duplicates or tracking unique items. The key takeaway is to choose the right data structure for the right job. While all three are powerful, understanding their unique characteristics and time complexity will allow you to write more efficient and maintainable JavaScript code. That's all for today. Thanks for watching.